Okay, I'm here. All right, can you guys hear me okay? I believe everybody finished the test. Let me just double check that real quick. And if everybody finished the test, we may take a look at it. So give me just a minute to run a quick little statistical analysis on the test. Hopefully it won't take a million years like it did last time. What'd you guys think? Was it hard? It probably was hard, right? And one person dropped. Don't drop the class yet. Talk to me first before you drop the class, before you even check and see what your test grade is.
Definitely a little more difficult than what I thought it would be, but
yeah, that's true. Whether it's at least from my tests, whether it's a regular semester and we're not doing this COVID-19 thing, that's what I get all the time, and that's because, and I expect people to do worse on the first test. That's because a lot of it is history, a lot of it is concept and basic information about what the layers are doing. Exam 2 and exam 3 should be easier for you guys, hopefully. So, and I'm going to be really lenient when I'm going through the tests and grading them to make sure that you know, I'm not discouraging anybody from continuing. Just make sure, like I said, I need to make sure everybody took the test. You should have all taken it, but I need to make sure everybody took it before I start talking about what's on the test, or what was on the test. And we'll take a look at a couple of the items that were maybe the most missed items here. Okay, looks like the only student that didn't take the test was my test user, which was me. So do you guys want to talk about the test then? Some stuff. Yes, sure. You guys, this is your opportunity too to look and see what some of the responses were. I'm not going to show anybody specific tests. I'm just looking at statistical analysis. Give me 1 second and I'll share my screen and you guys can take a look at the statistical analysis, which doesn't show anybody's specific grade. It just shows how many people missed at each question. Okay. This over here. So most of you thought it was pretty hard, huh? I haven't graded the essay part yet. No. Item analysis, that's what I'm looking for. All right, let's take a look at it and see what she wrote. Let me share my screen now. Okay, which screen are you seeing? Are you seeing the screen with MIS 4477 exam 1 on it?
Yes.
Okay, good. Just want to make sure I'm sharing the correct screen. All right, so let's take a look at the statistical analysis. Looks like the average score was 72.38, which is good for some of you in that that'll make a significant curve. Roll this up. Put this in order of average score. So we're going to obviously skip these because then we'll talk about the essay question in a minute. So let's take a look at some of these with a client-based architecture. One fundamental problem is that, let's take a look at that question with a client-based architecture. And bear in mind, some of you didn't get certain questions because it's pulled from a random pool. So if this doesn't look familiar to you, just be happy you didn't get that question. You got something else. So the client-based architecture, one fundamental problem is that, and the answer was there is no server and it's more difficult to keep track of the data. Now that's a bit of a trick question and it's caused problems in the past, so I'm probably going to throw that one out. Generally, if more than 50% of the people miss a question, I throw it out or I give everybody credit for it. So I did not say client server based. I want you guys to understand the difference between host based, client based, and client server based. It's three separate things. Host based programming or host based topology came first, then client based where there was no host, where you ran everything on your local computer and there was no network. Everything existed on the hard drive or the floppy drive back in the old days of that computer. So there was no server. This is almost the same thing as peer-to-peer, but it's not even networking. Any questions on that, by the way? Yeah, like I said, it was a little tricky. So it probably got some of you. And like I said, I'm going to toss that one out. Oh, I need to restructure it. I think I throw too many people off with saying client-based, and they think, oh, thick client or client-server technology. As far as most of you know, you guys have never been alive where there wasn't some sort of networking going on. If a computer's not connected, it's kind of useless. If a game console, does anybody play games on a game console and you're not playing a multi-user game? You're just playing local? Nobody does that anymore. Everybody plays connected. So let's see. Let's take a look at this one. I think more people should have gotten this one, but again, this is from the physical layer, which I did not do a class for. I kind of left it up to you guys, so I'm taking that into consideration. So that's why we're going over the test, and I want to reiterate some of these things. So with fiber optic cabling, why is fiber optic cabling not used more often on LANs to connect clients? And the answer is all of these reasons. Now, it looks like most of you put high cost, which is true. Fiber optic wiring and fiber optic networking cost more, but let's take a look at some of the other answers. Lack of mobility, which is often desired or needed in a client node. Well, that's also true. If you're tethered with a cable, whether it's fiber optic or not, you can't move around. And lower transmission speed requirements of a workstation. Do you understand what I meant when I said that? In other words, most workstations don't need a fiber optic connection. Are you watching 10 movies at one time? Or if you're working on a very complex CAD drawing, for example, if you've usually downloaded a local copy of it, you don't need a high-speed fiber connection for a client, for a workstation. We use fiber optic connections for server-to-server connections or a network to the internet connection. That's why you don't see it that often. Wi-Fi is the prevailing popular connectivity method. In fact, A lot of new laptops, a lot of new PCs don't even have any connections other than a power connection. There's no Ethernet port. In fact, I had this problem last night with a client where I was trying to help him reset up a gateway at his house. And I said, just connect up an Ethernet cable. He says, I got an Ethernet cable. He couldn't find an Ethernet port on his laptop because there aren't any anymore. You have to go buy a USB to Ethernet adapter. This is more true for Apple than it is. And then let's see, danger to the end user. Nobody chose that, but only one person chose lower transmission requirements. I want you guys to understand that fiber optic wiring and fiber optic networking is dangerous. Fiber optic light uses ultraviolet light, which you can't see, the human eye cannot see, but it will burn your iris, or not your iris, your cornea. So if you ever see a fiber optic wire laying on the ground, one end laying on the ground, and you don't know where the other end is, don't pick it up and look at it, like move it around like this, because it'll be performing surgery on the back of your eye. Can't see it. There's supposed to be warnings on fiber optic connections, or they're supposed to be protected well. Okay, so bottom line on this, again, since I didn't go through physical layer very well, everybody's going to get credit for that question anyway, okay? But I do want you to understand why all of those are negatives or positives, depending on how you look on it, for fiber optic wiring. This one, more people should have gotten this, but what is the term for an application layer address used in a browser that includes the address along with, and I think I mentioned this in the class, I thought I did. The term for an application layer address that's used in a browser that includes the address along with the protocol, as well as the TCP port number, and that's called the URL. Uniform Resource Locator. A lot of you put HTTP. That's a protocol. That's not the name, or that's not the term for an application layer address. An application layer address is where you say, I want you to go to http://www.uh.edu:80. That is a full URL, not just a web address. You guys understand that? I hope you're okay with that, but I may or may not. Well, I guess I'll have to throw that one out because too many people missed it. Most of you put HTTP. That would be an example of a protocol at that address. Why does Ethernet break data streams up into smaller pieces of no more than, let's take a look at the whole question, 1,500 bytes? And I know I mentioned this in class a few times, why there's a 1,500 byte limit. A lot of you put all these answers are correct. Let's look at each one. Since Ethernet is a shared network, data from different nodes must be interleaved, I did mention that, efficiently, and too big a piece would cause lag for other nodes. This increases the efficiency and throughput of data from one node to the next. No, it does not. The more that you break things up, the more overhead you create. And we've got none of the answers is correct, and all of the answers is correct. Since Ethernet requires error checking, the data stream must be broken into pieces to calculate checksums. That's technically true, but that's not the reason why. The primary reason why we break up frames, Ethernet frames, into little pieces is because Ethernet, specifically Wi-Fi, is a shared network, and you've got to interleave your traffic with everybody else's traffic. Any questions on that?
Yeah, sorry, just for, is there a specific reason why no more than 1,500? Why it's not like, I forgot if you mentioned that or not.
Well, yeah, I did mention that in a class period. Maybe you weren't here for that one, or maybe you missed it, but at some point a few years back when they were designing the Ethernet protocol, they determined that 1500 bytes is a good maximum value for standard Ethernet. And I did mention before that you can enable something called Ethernet super frames. And you can have Ethernet frames up to 10,000 bytes. But we only use that when we're, or sometimes they're called jumbo frames as well. They're only used when you're communicating from one server to another that are literally right next to each other. But why 1500 bytes Ethernet? You just Google that. How 1500 bytes became the MTU. The MTU, by the way, stands for maximum transmission unit. Didn't ask that on any test, but okay, there you go. So remember. What else have we got that was suspicious? And you guys can ask me about any of them if you want, if there's not one I'm going over, but let's just finish looking at the ones where most of you missed it. Okay, so I didn't talk about this in class because I didn't get to this, but this is significant, and I want you guys to understand here. A common source of occasional sporadic errors detected by the data link layer, which is talking to the physical layer, which can be fairly easily controlled in the physical layer, is RFI/EMI. First of all, do you know what RFI and EMI stand for? And you could have used Google, could have Googled these terms while you were taking the test. But RFI, I want everybody to know this, RFI stands for radio frequency interference. EMI stands for electromagnetic interference. Both of them are generally a type of radio wave interference. All networking, well, excuse me, all copper-based networking, electrical-based networking, not fiber optic, relies on waves or radio waves that travel through either a wire or the air. If there's other radio waves occurring at the same time that are interfering, that causes errors. The reason that's fairly easy to control, and that's what I was trying to point out here, is that you can shield the wiring, move the wiring away from the device that's causing the electromagnetic interference. Anything with a motor in it causes electromagnetic interference. A drill, a car engine even, an amplifier, a guitar amplifier. What did a lot of you put? Oh, a lot of you put attenuation at one point. What is attenuation? Attenuation is not fairly easy to control, because what attenuation means is it's the gradual weakening of a signal over distance. If you are on your laptop and you're sitting in your backyard and you are a couple hundred feet from your house, and that's where you need to be using your internet, that's not fairly easy to control. Or let me give you a better example. Let's say you're setting up a wireless camera somewhere out in your yard to take a look at your yard. That's more difficult to control. You're going to have to put something in place, and it's also not sporadic. Usually with signal weak degradation like that, it's fairly constant errors that occur, or you get no communication at all. So that was not the right answer there. And modulation, that term, that doesn't make any sense for that answer. Modulation, if you Google that question or that term, that just means the modification of a wave, either the height, which is called the amplitude, the frequency, which is how many per second we're saying, and then the phase, when it starts. Does it start at 5 volts and goes down to 0, or does it start at 0 and go up to 5? In other words, is it a sine wave? If you remember back from trig, sine wave versus cosine wave. Not asking you to get too technical here, but radio frequency interference. That's why we like fiber optic wiring in terms of using networking for servers to communicate with each other, or we're communicating over long distances. We try to use fiber optics because Fiber optics are not affected by radio frequency interference. Let's see. I'll maybe do a couple more unless you guys see one that you want to ask a question on here. A client computer is typically assigned a network layer address. So first of all, what addresses exist at layer 3, aka the network layer? That's an IP address. And the answer was DHCP, which leases a temporary address. A lot of you got it right, but several of you put hardware manufacturers. That's because you're getting the data link layer and the network layer mixed up. And that's probably the biggest issue that I see with early learners of this information. Data link layer, layer 2 is for LAN only. You don't even need a network layer if you're never going to send messages out of your LAN. If it's just, you've got a computer and you want to talk to a printer that's connected on your network. They don't need IP addresses. They don't need a network layer. They can communicate a data link layer. So at layer 3, the network layer, most of us don't have to hard code or know what an IP address is because it's delivered via DHCP. Okay, go look that up if you weren't sure about that one. Again, I'll probably curve and give credit for that, but that's not really fair to the 10 people that did get it right, though. But that's just the way the cookie bounces. I try to be fair. I know my first test, and I probably should have warned you guys, my first tests are kind of ass kickers. Excuse me, not kissers. They kick ass, the first test. And that's, again, because a lot of it is history and concept and without a lot of hands-on yet. Are there any others here? I'm just going to scroll slowly through here. Are there any others here that anybody wants me to explain? Want me to explain it to them? Not seeing anything in chat. Can I go over the question susceptible noise? Is it on this page somewhere?
Yes. Can you go back to the page and scroll down?
I was trying to do a search for it.
Yeah, if you,
That
so
one?
it's that one. And then after that, if you can go over
Okay.
2 questions down.
Okay. And again, I wish I would have gone. Don't say that one more time. That last part.
2 questions down where it says refers to a group of computers that are logically grouped together.
Oh, that there? Okay.
Yes.
So let's look at this one. First of all, and again, I didn't go over this in class, but it's in the notes. There's 2 media types, 2 general groupings of media types. There's guided media and radiated media. Did you get that concept? First of all, radiated media is wireless.
Yes, I got that concept, but the answer was incorrect. So I was just trying to understand why.
Well, the answer was UTP. So what that required you to do is look up what each of those was. So if you just Google for it, here's a good way to Google for stuff in my class. You see a term, sometimes the term's a little too generic, put the word network or networking in front of it. So if you'd Google for network space UTP, network space STP, network space coax, it would have described all of these things, network space fiber, network space wireless. So several people put wireless as the answer. Well, at least 4 people put wireless. What did you put, if you don't mind me asking?
I put the 3rd one, coax.
Coax. Okay, so
Coax, yeah.
let's first answer the question why it can't possibly be wireless, because wireless is not a guided media. It's radiated, so it's a little bit of a trick question. Right. The reason
I was stuck with between fiber and coax. So, and then I ended up.
Fiber.
Yeah.
I'll just tell you right up front, guys, if money was no object and you wanted the fastest possible, most reliable network that you can string for dozens of miles on one piece of wire, use fiber. Fiber optic wire, and it's the most secure because you can't really, you can't easily jack into fiber because people aren't just carrying a little $20 switch in their pocket that you can jack into an Ethernet with. Fiber equipment costs a lot more. So the answer here is unshielded twisted pair. That's what UTP stands for. That's basically telephone wire, old school telephone wire. There's no shielding around it. It's just the wires are twisted around each other. Shielded twisted pair, which is what the STP stands for. There's a little bit of cellophane, or not cellophane, but like foil shielding around it. But coax, and this is why Comcast uses coax. AT&T uses an unshielded twisted pair, and they cannot stretch their networks as far. Comcast can stretch their networks for many more miles because they use coax cable. So if you were to Google coax versus UTP, coaxial means, and there's different flavors of coax. There's one wire in the center, and then it's surrounded by an insulator first, and then a very good braided shield in most cases. Coax can send signals much further.
Yeah, thank you.
Okay.
Makes sense now.
Okay. And then that other question, whoops, went too far back. Or was that it? Let's see, no, that was not
That
it.
one was 2 questions.
One here?
Yes.
Okay,
Yes.
let's take a look. A blank refers to a group of computers that are logically grouped together at the network layer. Most of you put the correct term, which is subnet. And I've mentioned several times because we were talking about these subnetting assignment and how we're using IP addresses. It's called a subnet, not necessarily a LAN. LAN is data link layer. Again, there's that layer 2 versus layer 3. Back in the old days, before there was IP, we've had LANs for a long time. We've had LANs since the late 70s. We had a layer 1, a layer 2, and then a layer 5. Well, we didn't call it layer 5, but we went 1, 2, 5. We stuck the 3 and the 4 in there because we needed a way for our LAN to communicate with another LAN or the internet, some other LAN. So the answer here was subnet. So they're similar, and some people use these terms interchangeably, but I want you to understand the basic fundamental difference between a LAN is those computers are all physically connected to each other in some way. In a subnet, they're connected to each other or related to each other by IP address. They may not be on the same LAN. For example, if you've got your VPN set up or you're setting up VPN to connect into the EI lab, you are not part of the EI lab LAN, but you do become part of the EI lab subnet. You end up getting on that subnet so that your IP traffic is 192.168, whatever, instead of whatever you were getting if you were at home. So, do you understand the difference? Did I talk about it enough?
Yeah, I understand it now. Thank you.
Any other questions? Anybody else want to look at anything? I can, I'm at the bottom here. I'm going to skip. Let's see. There's a subsequent pages here. There's some more. I'll scroll through them slowly, and somebody either turn your mic on or type a bunch of asterisks or something. Contention-based networks. Is that on this page here? Or is that on the previous page, Franklin?
Yeah, that was, if you scroll up a little to the top, it didn't have a red dot on it, but I had a issue with that one. It just said contention. I think it's a really short question. It just says contention-based networks.
Do you see it on the screen?
Let me see. No, if you scroll up a little bit.
You want to go back to the previous page? I put these in order of hardest to easiest question.
Okay.
Go back to the previous page here. It might be on the previous page. That,
Yeah, right there. Yes.
okay. Contention-based networks. And I did talk about this in class. Contention-based networks, which is Ethernet, which is Wi-Fi, where you are contending for that space. Think again, you're supposed to be thinking about a LAN or a network as essentially a 1 or 2 lane highway where you have exclusive use of that highway from point A to point B at any one point in time. It's not a multi-lane highway, so it's contention-based. Contention-based networks work better than controlled approaches for small networks. Think of the analogy that I gave where when you have a small group of people, 5 or 6 people, let's say, you use a contention-based approach for communication. In other words, you did not use a controlled approach, like you don't raise your hand, say, I'd like to say something now, and you don't require everybody to, okay, stop. Let's listen to Jake because he's got his hand up. Or there is not a proctor or a teacher or a controller saying, oh, you've got your hand up, I'll let you talk while your hand is up. You don't need that in a small group, but if you have a group of 100 people, you can't use contention-based because everybody would be talking on top of everybody. So on a small LAN, contention-based networking works better. On large LANs, which are, we don't typically have large LANs anymore, we have large backbone networks and large internet networks. We do have to use some sort of controlled approach to networking. Does that help you? It was trying to get you guys to understand the difference between Ethernet, which is contention-based, and networking protocols that are controlled, such as ArcNet or PPP.
Yes, it did. Thank you. And just a quick question on the example. Does it say that on the question where it's broken up by like the total? Is that how many people selected an answer? Oh, I think you got rid of it. But...
Yes, okay. And keep in mind that score right there.
No, I meant in the sense like that question we were just looking at. I chose an answer and it showed that nobody chose that answer, so that's why I was.
Which answer did you choose?
I chose C.
Contention-based networks are quickly replacing controlled approaches. You sure you chose C?
Yeah, that's what it shows up.
Because it says nobody chose C.
Yeah, that's why I was saying that it was a little strange because yeah, that's what I have and it shows that nobody selected it. But...
Tell you what, send me an email. And
no, I would have got it wrong anyways. I mean, I was just.
I know, but I want to check this. So send me an email anyway and say, hey man, I know I put D or something. I didn't put that as the answer.
Okay.
Or tell me I put C as an answer, but it's not showing up there. Or and again, your C might have been a B or a D. It might have been something else, but the content of the answer. You're pretty sure you chose are quickly replacing controlled network approaches.
Yeah, that's what it shows on mine. It just says what my selected answer was, and it says E, are quickly replacing controlled network approaches.
Okay.
So.
Yeah, again, send me an email. I want to look at that and see if there's not some sort of a glitch or an issue with that. All right.
Okay. Yes, sir. I'll send you that.
Thank you. Appreciate that. Okay, so let's take a look at. I haven't graded the essay questions yet. I'll be doing that this evening. So, but let's go ahead and take a look at the essay question answers. So, this was basically pretty open season on what you could write. So let's just take this first one. Layer 1. Describe what layer 1 of the internet model is for, and how does this layer significantly differ from all of the other layers. Now, what I didn't want you guys to do, and most of you don't usually, is just copy and paste something that you read off of PowerPoint or the internet, rewrite it in your own words. I can tell when you copy and paste because a lot of times the font is different. But when you rewrite it, even if it's not your own words, as long as you rewrite it, the process of reading something and then sending it out your fingers into a keyboard, for some reason that creates a more permanent memory link. Okay, that's why people take notes, or that's why that's good to take notes rather than just listen to what somebody's saying. You're much more likely to remember something if you wrote it down. Even if you don't go back and look at those notes. I take notes all the time, never read them, but it helps me remember stuff. Okay, so I can't stress that enough. I know that you've got a lot of you graduating seniors and you're almost done with college, but still, for the rest of your lives, do that. Don't stop learning after this class, after this college degree you're working on. So describe what layer 1 was. I was looking for, layer 1 is the physical layer, so you needed to first name it. Layer 1 is the physical layer. It is the layer in which we as end users interact with. And this is also the layer in which our data is physically stored in terms of bits and the ones in the electrical signaling. It's how we interact with the network layer. It's where everything starts and not really necessarily ends. But it's different. It's significantly different from every other layer because it is not code. It's hardware. It's anything that you can touch. All the other layers are some flavor of code, whether it's C coding or Perl script or HTTP or transport layer protocol, whatever it is, it's code that somebody wrote. Okay, so that's what I was looking for on that. Fairly short, 2 or 3 sentences. That's all I needed for that. Okay. Question number on the question regarding, and again, you might have gotten these in a different order, but layer 2, what are the responsibilities for layer 2? There are 3 things that layer 2 is responsible for. One of them, the first one is media access control, because Ethernet is a contention-based network. We have to have some way to control the network, decide who gets to talk when. The second thing that layer does is error correction, because errors occur because of the physical layer. And then the third thing that the data link layer does is called message delineation. And if you just wrote that, I would prefer that you tell me what does message delineation mean. And you needed to say something like it indicates the start and the end of a frame. And that's because, again, all the data that's coming into and going out of your computer is on one road. There's one road and there's ones and zeros that are lining up one after the other. It's not a parallel bus type network like what's inside your computer. It's a serial network. Networking is serial. You guys know the difference between serial and parallel? Serial is like when you want to get into a building, into a club or a movie or whatever, you have to line up one at a time. Each person goes in, whereas parallel means that there are 8 doors or 16 doors or 32 doors, and 8 or 16 or 32 people can all go in at the same time. That's called parallel. That's actually what's going on inside your computer, by the way. That's why there's all those line tracings. That's why you have slots inside computers. There's multiple highways inside a computer. So message delineation, that's what I was looking for. Error control, message delineation, and controlling the media. Layer 3, what does layer 3 do? Layer 3 is called the network layer. It's responsible for routing and addressing packets. I was looking also for the word packet, not just messages. I wanted you to name what the PDU is called. It's for routing and addressing packets. So your computer can figure out, hey, is this chunk of information destined for a computer on my local subnet, or do I need to send it to the gateway computer or the gateway device so that it can send it out onto the wild internet? That's why we're learning this IP version 4. The network layer is also responsible for addressing the message is adding the source and destination IP address, which is usually learned via DHCP. Layer 4, that's called the transport layer. What's that? And let's see, why do we need a layer 4? Back in the old days with single threaded computers that are only run one program at a time, we didn't really need a layer 4. The reason we need a layer 4 is because our computers run multiple programs. We're running an email program, a web browser, a game, we're running, streaming video, streaming audio. We're running multiple things at once. So because we're running multiple things at once, we've got to have a specific port number for each one of those things running. That's why somebody decided a long time ago with the current TCP version we're using, 65536 was a good number. They figured, well, there may be 65,536 unique services going on one computer. We're good for a while on that. Eventually, we'll have to go to TCP version, whatever, the next version. But we're good for now. Don't just name and explain why it's needed. And it's because that's what we use to tie our data to the application layer. Port 80 means, oh, the transport layer, port 80 means, oh, I need to give this to the web browser or the web server. Port 25, oh, I need to give that to the email program. Let him deal with it. Never heard. I'm trying to be sexist. Okay. And then finally, layer 5. What is layer 5 used for and what makes it different from all of the other layers? Don't just name it layer 5. So you can say layer 5 is the application layer. It's used to perform the work, perform the function that the end user is trying to achieve. Or it's there to provide the data, the information that an end user is requesting from a server. It depends on whether it's an application layer on a server or an application layer on a client, but they're essentially doing the same thing. What makes it different from all of the other layers? It is the only layer that our information that's in here, our brain information, or the conceptual information, that's what I'm talking about. That's the only layer that the conceptual information is understood by humans. We don't, as humans, we don't talk transport layer. We don't go 80, 25, 33. And we don't talk IP. We don't need to talk IP. And we don't talk data link layer. And we don't talk radio frequencies. We might talk in HTML, but we talk in text. We talk in audio. We talk in video. That is our human interaction. That's what I was looking for. It's the human entry into the network model. The physical layer, and they're similar because it's the human concept entry at the application layer, and at the physical layer, it's the human physical entry and exit. To get our thoughts out of our brain, we have to conceptually come up with a thought and then send it to our physical fingers or our mouths or our eyes. We can't just telekinetically think something and have somebody else know what we're talking about. So the point is that that's where our concepts live. Everything else is just there to support the concepts that we're trying to send back and forth between a sender and a receiver. Okay, so over the next day, give me a little bit of time. Hopefully I'll have all of it graded tonight. I've got some stuff I've got to do, but I'm going to try to get 30-something tests graded so that I can get your grade up so that you're not worried about, geez, what did I make on the test? I'll put a curve on there if necessary. Now, the reason that number is probably that low, by the way, is because now that I think about it, it could not possibly have graded the essay part, which I believe is 20% of the test. So that's probably why that number is so low. Let me grade everything, post it, and then you can email and cry to me or consider dropping the class or whatever. But again, I think you guys will be happy with whatever curve I end up putting on there.
So do you have an idea of how many points will the curve be?
No, I have no idea yet. That's what I said. I've got to look.
Okay.
I've got to look at, I'm looking at the statistical analysis, but I've got to grade the essays. Otherwise, I really can't say what the curve's going to be. You know, if everybody did perfect on the essay, I don't see the curve being more than 8 points. I don't think everybody did perfect though, so we'll see. We'll see how it goes. Curve might be 18 points. We'll see what happens, okay? Now, I don't think it presented a grade to you, did it? I think it says it's ungraded, correct? But
Correct, yeah. It
Yes,
does tell you which
correct.
ones you got
I
right and
believe-
wrong.
I believe I told it to show you guys your incorrect answers in Blackboard. You should be able to go in there and see which ones you got incorrect in Blackboard. So correct me if I'm wrong on that. Let's go
Yeah.
ahead. What's that?
No, I was just saying, yeah, that's correct. Like we get to see the incorrect answer.
All right, thank you.
Mhm.
Let's go ahead and finish up. I was going to record a separate recording for network design, but let's just go ahead and finish that up today. The network design chapter, because as I said, chapters 7, 8, and 9, or at least 7 and 8 will go a lot faster than 6, the network design part. And network design, in my opinion, is more important than understanding the conceptual topology difference between a LAN, a backbone network, and a WAN, because as far as I'm concerned, for management purposes, they're not that different. It's just a matter of how far back you're standing from a network. How close are you? Are you looking at 3 computers, or are you looking at 3,000 networks? You know, so it's just how far you're zoomed in. So let's go to course content here. Let me download chapter 6 again. And by the way, there is exam 2 will be coming up pretty soon. It's just going to be chapter 6 through 9. The study notes are already there. I know it's for the previous semester, but I don't change the test that much, if at all. So you can start looking at the study notes even now. Start preparing yourself. Looks like I've downloaded it before. That's okay. We'll just download it again. PowerPointless. Slow. Okay, I think we're about to, we're right about there. No, actually, we were just past here, and I was talking about the differences, and I think this is conceptually easy to understand why we need to do this and categorize everything, and that's because ultimately it's going to boil down to how much money do you have in the budget to upgrade a network, to enhance a network, to build a network if you don't have any network at all. You've got to have these things categorized because you're having to answer to a company controller or a board of directors or taxpayers if you're a public entity like University of Houston, for example. Here is, and we can use draw.io for this. This is a conceptual. This is not a physical layer drawing. This is, think about this as a conceptual needs map. Pretend this is the Melcher Hall. We have 3 floors in Melcher Hall, and we've got, this is just an example, multiple functional groups, usually LANs, not always, but usually LANs are broken up by either close proximity or functional operating group, an engineering group, for example, or a sales group, or an inventory control group, or accounting group, or they are physically near each other because it's a general LAN for like a lab, like one of the labs that we have here that anybody can use the lab computers. You know, you each might be a different a different major. Here, you might be an employee working in a different area, but if you're using a general LAN, like a wireless LAN, then that's a different reason for grouping it together. So when you're creating a logical network design, and this is the deliverable out of the needs analysis should include, on top of a lot of text and typing things out, this is what I think we need. I think we need to use, Microsoft Windows 10 for our desktops, and we need to use, Apache for our web servers, whatever it is. If we are designing or redesigning a physical network, we need to come up with a logical set of, logical set of how we describe our LANs. Here, this LAN here, we describe it as a typical use LAN. Here, this is a high traffic LAN, and that might be because this functional group, maybe they're an engineering group where they need to have a high-speed network to get those CAD drawings up and down. Or maybe this is where my server room is in the building. So I need a high-speed network. I need high-speed traffic coming from this area because all these other groups are going to be using data from there. Okay. We don't specify on this map, and what you won't see are brands of anything. Usernames, things like that. You see generalized statements about what your and it could be geographically accurate, but it usually is not. It's usually not geographically accurate like this. Meaning, we got 3 floors in a building, so this is drawn with 3 different layers, but not always. Technology design. This is the part that makes more sense to most people. This is where we develop a physical network design or a set of possible designs, which literally does state the speeds of the network devices, the amount of memory, and more physical information about the workstations and the clients and servers and the applications as well. What applications we need. It's all in technology design. It includes clients, servers, the circuits, networking devices, the routers, the switches, the gateways, access points, what new hardware needs to be purchased, and it might even list technology design many times, literally lists the brand names out, especially if it's a special purpose device like a firewall, for example. And you're required perhaps by some compliancy rule, like you work for the state of Texas, or you're doing business with a certain entity, which requires a minimum level of compliancy, which perhaps only Cisco and a couple of other manufacturers of firewalls have. Can the existing equipment that's there be upgraded? So we may be indicating server number 25, which is in this area. We simply just need to add a couple more hard drives to it and some more memory, and that's what we need to do to that. And we literally state what we're doing to that physical device. Designing clients and servers, we specify the devices needed in standard units. X amount of, or seats, sometimes we call it seats. We break down our users sometimes into 3 groups, not just 2 groups: a typical user and an advanced user. An advanced user needs obviously more or different applications and perhaps different hardware allocated to them. Like I said before, maybe they're an engineering group and they need big monitors, lots of RAM, specialized pointing devices, stuff that doesn't make any sense for an accounting person to have, whether they would love to have it or not. They don't need a $4,000 video card. Some of these CAD drawing stations that some engineers are using that work for the oil companies in town, they're using just the network card, just the video card alone in their workstation costs $4,000 to $5,000. Forget about the rest of the computer. That's the cost of 10 computers right there, 10 clerical style computers. Definitions of typical and advanced changes as hardware costs fail. Now, this is inevitable in most cases. Hardware cost, for the most part, drops or it used to drop. Hardware's gotten much cheaper. Back in the old days, computer equipment was very expensive, and you could not buy fast enough computer equipment, no matter how much money you have. But these days, you can buy fairly fast computer equipment for not much money. And a lot of times you make the conscious choice not to buy the highest, fastest piece of computer equipment because you don't need it. Or the best piece of computer equipment. You don't need 32-inch curved monitors for your clerical workers. 22 inches good enough. You don't need 64 terabytes of hard drive space in a workstation. You don't need 32 gigs of RAM in a workstation for a clerical person. They can get by with 8. But I remember back in the old days where we were spending as much money as we could to buy the absolute top of the line processors. Nowadays, when I buy processors, I'm down here at the $200 or $300 range, knowing that there's $2,000 to $3,000 range processors, but they're not incrementally that much better. Maybe they're 3 times faster, 5 times faster, but unless I'm crunching 2 million records or trying to draw something on the screen, or a high-end gamer where I need 400 frames per second or whatever, I don't need the highest level of equipment. So it's inevitable. Hardware goes down. What is going up? There's a popular chart that we like to show people. It looks like an X like this. People used to be really cheap. People were down here back in about the mid 80s. This changed. Computers were really expensive and people were real cheap. You could hire a computer programmer for like $15 an hour. These days, what's happened? People are really expensive now and computers are dirt cheap. So if people are real expensive and computers are real cheap, when we're managing cost, what should we look at, by the way, when we get to that chapter? People. How can we eliminate some people, or can we get fewer people to do more with better equipment? So we spend a little bit more money on better equipment to hopefully reduce the cost of the amount of people that we need, the amount of FTEs. What is this about? Right next week, Friday, it will be posted. Are you talking about the exam 1 grade? It'll be posted.
Talking about the next exam, you mentioned that was going to be.
Oh, yeah, next exam. Well, it depends on if we get through chapters 8 and 9 by, let's see, today is Wednesday, right? Am I right? The days run together these days. Let me check here.
Yeah, today's Wednesday.
Thank you. Well, for a lot of us that are locked down, and I'm not locked down, but I literally work every day, so sometimes I can't tell what day it is. Although, why was there so much traffic on the road today? If all you people are home, why was there stop and go traffic on 59? Anyway, sorry. Probably by Tuesday, I'm thinking that the exam 2 will be available for you guys to take. Maybe even Monday.
Okay, so it will basically be posted the next day once we're done with the chapters.
Yeah, once we're done with chapter 9. Chapter 6 through 9 is what's going to be on exam 2, and subnetting. The subnetting stuff that we went over, and this is why it's very important that you not only complete, but turn in the subnetting assignment as soon as you can, so that I have an opportunity to grade it, or so that if you do the auto grading version, the version 1.0G, that it grades it for you. And if you get a 95 or above, then yeah, you're probably doing it right. Because if you don't understand that subnetting part, IP version 4 subnetting, the best grade, if you flunk it, you flub it all up, the best you can get on exam 2 is 75%, because it's literally 25% of the test. Okay, here's a few terms that you need to know. Capacity planning. This is defined as the estimation of circuit size and type required for each network architectural component. When we're planning networks, by the way, in terms of looking into the future, we never look beyond 3 years. So when we're planning for capacity, we look about 3 years into the future. We try to look 3 years into the future to determine not what kind of hardware may be available 3 years from now, but what our needs are 3 years from now in terms of how many employees we have or plan to have, what applications those employees are going to be using, what might change in terms of employee behavior, or for example, everybody's now working from home, which really caused a big problem for a lot of companies because they may have had very good internet connections to download stuff to their local sites. And that's because most internet service is asymmetrical. You have a very fast download speed, you have a very small upload speed. You have a unlimited speed limit down, but you can only go 10 miles an hour back the other way. That's bad for remote access, because if you're trying to remote access all of your data or your workstation that's sitting on your desk back at your company, that's the upload speed becomes the bottleneck. So a lot of organizations had to quickly scramble and either upgrade their connections so that they were more symmetrical or they had faster upload speeds, or they had to quickly figure out how can we migrate all of this data and all of these applications into the cloud so this stuff doesn't live at our actual physical site. So our employees don't have to access their desktop on their desk at work, so they can just access a virtual machine or just access the data and run the apps at home on their home computer. Another term here, circuit loading, is an assessment of the amount of data transferred across a circuit currently or in the future. Circuit loading is usually measured in bits per second, megabits per second, gigabits per second. Not bytes, but bits. Do you guys all know the difference between a byte and a bit? A bit is just a 1 and a 0. And it's sometimes misleading when you hear speeds, like when Comcast or AT&T tells you, we're giving you gigabit speed. First of all, understand that that is a maximum of gigabit internet, but both of those network types, both of those internet types are shared networks. If there's other people in your neighborhood downloading or streaming a bunch of information, you may not get that gigabit speed. It might burst up to that maximum level. In other words, that's your maximum capacity, but the circuit loading a lot of times is quite variable. Usually it's time-based. For example, between the hours of 6 and 10 p.m., not right now, but during normal periods of normal human behavior, home networking starts to lag quite a bit. And that's because people are coming home from work and they're starting to watch TV or stream Netflix or stream Disney or whatever their kids are doing, playing games or whatever. And then people generally go to sleep between 10 o'clock and midnight. So the actual circuit loading goes way down, even though the capacity is way up here. So when Comcast and AT&T say you've got a gigabit per second network, you have to always take that number and divide it by 8 in terms of the number of bytes that you're getting, the number of characters on a screen, for example. At least 8, sometimes more than 8. So a gigabit network is really only about 100 megabyte network, 100 megabytes per second. We don't specify file sizes in bits, we specify file sizes in bytes. A lot of network managers make that mistake when they're doing their capacity planning. And they go, okay, well, we need to be able to transfer 14 terabytes of data from point A to point Z every night for a backup, for example. And they start doing some calculation and they figure out, okay, we can use 2 gigabit networking to get this upload within a certain amount of hours so that it completes before the morning shift comes on. Gigabytes, gigabits, bits per second, BPS is different. It's usually written, by the way, like this. If you see G in a little BPS like that, that means gigabit per second. If you see GB PS like that, that's gigabytes per second. But I guarantee you, no internet provider tells you what the gigabyte throughput rate is, because it's a smaller number. Everybody's going to give you the a higher number to make it sound like they're faster. Okay? Estimating circuit traffic is many times very difficult. What we try to do as network managers is we use software, and we use tools, and we use applications which monitor over time. We usually need to take a snapshot of 1 week or even 1 month or a couple of months of data so that we can determine where our peaks occur and where valleys occur. And what we're looking for is we're trying to even out our network usage. We don't like to see peaks. We need to assume occasionally we do have peak traffic. When, by the way, do you think for most companies, not for individuals, but most companies, their peak traffic throughput is actually occurring when? At 3 in the morning. Why is it occurring at 3 in the morning, at least for upload? Because we're doing our backups at 3 in the morning. Why do we do backups at 3 in the morning? Because you don't want to be doing backups on data that's constantly changing, when data is not changing very much. Do it in the middle of the night. Also, if a backup fails or something happens to it, it doesn't take your network down. It doesn't cause a problem. It can be restarted. So backups are typically done either in the middle of the night, or if you're a 24/7 company, they're done when there is low peak times. Estimating message volume, counting the number of messages sent to the network, and again, we use graphing tools for this. MRTG, for example. Precision is not the major concern, down to the very byte, the very bit, and that's because, first of all, it's just averages that we're looking at, and secondly, when we are ordering circuit types, circuits only come in certain flavors, only come in certain sizes. Like, for example, with Comcast, or with Xfinity, I should say, since you're familiar with Xfinity, you can buy their Lifeline 10 meg down, 1 meg up service, or you can buy their 25 meg service, or 50, or 100, or 250, or 500. Starts jumping up a lot. They don't fine tune it for you, and they don't typically fine tune it for businesses either. You have a limited set of speeds you can choose from. And sometimes those speed differences are extreme. It goes from 1 megabit per second to 10 megabits per second. So you pay a certain rate here for 1 megabit, or you can jump up to 10 times the speed and get 10 megabit. That doesn't usually cost 10 times more. Or you can go to 100 megabit, another 10 times the speed, and that doesn't typically cost 10 times more either. So we don't really care that much about precision. In fact, a lot of times we have to buy a circuit which is going to be much greater than what we need right now, and that's usually because these circuits, when you sign up with these contracts, they're 3 to 5 year contracts. You can't make changes. Well, actually, sometimes you can make changes, but you can't typically go down. Go up, but you can't go down. Standard circuit speeds are stair-stepped. We call it stair-stepped, and it's not really very stair-stepped with Xfinity. It goes 10, 25, 50, 100, 250, 500. Those are some big-ass steps, you know what I'm saying? They start small and get big. Traffic typically increases more than anticipated. I always tell network managers, okay, you've been looking at some traffic for the last week. You figured out that your average throughput, your nominal throughput, where there's not a bunch of peaks happening, 80% of the time you're at about 60 megabits per second. Multiply that by 50%, at least 50%, 75% right now, because chances are a year from now you're going to be needing much more bandwidth, because all of our aspects of business that used to be handled some other way, like telephone calls on a separate network, or what we're doing right now, which used to be face-to-face, we're doing it on video, which is a huge, extreme hog of bandwidth. Video eats up bandwidth. I'm glad that, we're lucky that we have fairly good internet services here in the United States. and then you're not in a rural area. Maybe some of you are in a rural area, but if you're on satellite internet connection, two-way service for video is nearly impossible. One-way might be okay. Two-way, nearly impossible. Should network designers plan for excess capacity? Absolutely. Just mentioned this, 50 to 80% more, because it always costs more money a year from now to renegotiate and redesign than if you just plan for the excess capacity to start with. It's like buying a house or renting an apartment. You buy a house now, maybe you're a single guy or a single girl, you don't have a family yet, but buying a house is a pretty major deal. You don't want to be buying a house every 3 years. It's expensive. And 5 years from now, what's the likelihood of me having a spouse and a couple of kids? It depends on you, but for a lot of us, it's a lot of young people, it's very likely. Maybe I should buy a 3-bedroom house because I want to amortize and I want to live in this house for at least 10 years, at least 15 years before I consider buying another house. Because I don't know if moving, pain, the older that you get, the less and less and less you want to move, because the more shit you have, you know what I mean? You just accumulate stuff over time. It's like, how did I end up with 5 televisions and 3 couches and 6 beds and so much crap, so much stuff? People end up, as they grow, when you're fresh out of high school or fresh out of college, you ain't got much. But when you're 45 and you've gone through a couple of divorces, you got a lot of stuff. Or a couple of remarriages, I should say. Turnpike effect, that term just means that occurs when traffic increases faster than forecast. This has happened with a lot of companies because they're having to do the Zoom meeting now. And this is why so many companies are having issues with this Zoom meeting, not just because Zoom was a weird a new platform, not just because it was new for people, but because they did not have the bandwidth infrastructure in place to have Zoom meetings. So they ended up having to do something alternatively. Well, it's not working here. I guess we're just all going to have to, go use somebody else's network for our meetings, host a Zoom meeting some other way, or not do Zoom. Okay, network design tools. I'm going to mention a couple of network design tools. First of all, I've already told you about draw.io. That is a network modeling tool. Modeling tools are fairly inexpensive. They're fairly simple. Most of them are drawing-based tools, like Visio, like draw.io. Network discovery tools would be tools like the advanced IP scanner and then the advanced port scanner. Now, correct me if I'm wrong. Didn't I have you guys look for and use the advanced IP and port scanner in class? Or was that the 4397 class? I think I had you guys do this, not for a grade, but that would be an example of a network discovery tool. It doesn't necessarily model a network. It can model a network. I mean, a lot of the discovery tools, once it determines everything that lives on your network, then you can turn it into icons and move it all around where you think it actually is. But network discovery tools are invaluable. Most of them cost money. Most of them are not free, but they give you a little free taste. They give you a free version. And then the ones that actually give you much more information about the devices, especially if you're using software that you install this software on all of the devices and let all the devices communicate with each other, then they can share statistical information, how many users are logged in. Excuse me, let me fix my lights. How much data is going through this network. Advanced IP scanner doesn't do that. It looks blindly it's just knocking on doors. That's all that IP scanner's doing. Hello, is anybody home? Who's home? It depends on who feels like answering the door. A lot of servers don't answer the door. They're like, I'm going to ignore you because you're just knocking. You're not actually asking with the right credentials to be let in. You don't have keys. I'm not going to let you in. That's a network discovery tool. There are more expensive tools that some larger companies use, which are simulation tools. They might be like some of these discovery tools, but they allow you to create an existing network, or create a network, either an existing one or model a new network. And it will allow you to draw circuits between clients and servers and then simulate adding a backup or simulate adding a certain application onto the network with X amount of users. X amount of users running Zoom, for example. What will that do to my network throughput? What does it spike up to? Usually the simulation tools cost money. I can go Google for them and you can go Google for them. I don't have any good examples to show you. Because the one I used to use is not available anymore. These usually cost money, but for higher end networks or large networks like University of Houston network, you bet we use simulation tools and we put in things like, well, if our student body increases by 15% or decreases by 15% in the next semester, which it probably is going to. Or let me put it this way, our student online presence increases by 15 to 20%, because a lot of classes have decided, you know what, come fall, we're going to teach at least half of our classes or more on Zoom. Live video, so that's going to significantly affect the requirement for U of H's networking and where that networking money is spent. We're not going to spend any more money on building labs here. Like, what do we need labs at U of H for? We need to take all that money and improve our network infrastructure. So, and forget about the Wi-Fi because nobody's here. Get that internet connection boosted up. Okay. The deliverables from the technology design are basically taking those logical maps and literally putting in specific types of hardware, not necessarily brands, but we're specifying, for example, on each one of these floors, we need a network switch. By the way, that's the generic icon for switch. It's a box or a rectangle with lines drawn in both directions because it's switching data around. We use this for router. We use a cylinder with arrows pointing to the center and not coming out, although data does come out. The difference, by the way, between a switch and a router, does anybody know? What's the fundamental difference between a switch and a router? Switches work at layer 2 only. You don't have to program them. Routers work at layer 2 and layer 3. They all work at layer 1 because there's physical connections. Switches only will care about MAC address. In other words, they define a LAN. Routers define a subnet. Routers do have to be programmed. It's a finer control of the data. It's kind of like the difference between having a 4-way stop or stop signs in a neighborhood versus having traffic lights or a traffic controller in certain areas. Where there's more traffic, you see traffic lights, or you see a traffic traffic cop. Some countries still use cops in a road, direct traffic. No need for something like that within a neighborhood where there's not much traffic, but wherever you see all of the connections terminating into one single connection that needs to be much higher speed network, you'll see a router being used because we need that better control of the network traffic. Routers layer 3, switches layer 2. Cost assessment. This is the least fun of the 3, but it's usually where we get stuck, at least us as network managers, because we're like, I want to spend a whole bunch of money on my network. In my particular workstation, I would like to have, of course, the nicest workstation. Cost assessment is a financial analysis of the various technology design alternatives. It's a very complex process sometimes because depending on the scope of your design, it could include some or all of these items. The cost of the circuits, which could be the cabling that needs to be run, and the installation costs, the internetworking devices, the switches, the routers, the gateways, The hardware cost, and also the maintenance cost, the ongoing maintenance. There's usually two components when you're talking about the cost of any of this, is the installation cost, and then the monthly recurring maintenance cost or insurance or required cost that you need. Because if this stuff breaks down, you need to be able to call somebody and get them to repair it or replace it or fix it. Just because it's under warranty doesn't mean, okay, it's under warranty, that means it's not going to break. So it's under warranty. If it breaks, somebody's still got to take it to the store or send it back to Amazon or call HPE and get them to get their butt in there and fix or replace whatever it is that broke. For some reason, a lot of end users believe it's got a 5-year warranty, so it's going to last 5 years. No, not just warranties. If you buy something that has a 30-day warranty versus something that has a 5-year warranty, doesn't guarantee quality difference at all. Only thing it guarantees is that you paid more for the 5-year version. Biggest moneymaker, by the way, for most companies that are selling networking hardware is, and I know that you guys have seen this before, you go buy something on Amazon.com and they ask you, hey, would you like the 2-year or the 4-year protection plan to add insurance onto this piece of hardware you're buying? That's their way of trying to make extra money off of you. They've made their money. They have a certain cost that they have to pay for a piece of hardware. Anything that you pay them additional to that up front, that's just gravy for them. And that's because they know 2 to 4 years from now, you might not be the owner of that equipment. That equipment will be obsolete. So if it does break, you're like, screw it, it's broken. I'll go upgrade to my 1 terabyte drive broke. I'll go buy a 4 terabyte drive because now they're dirt cheap. They know that. Anyway, you have to take those into consideration. Hardware costs, software costs, network operations and management and maintenance costs. I mentioned that. And this right here, this is the biggest cost. Hardware doesn't cost that much. It is the maintenance contracts and the salaries of guys like me that fix stuff when it does break, not the hardware when it fails, but when the end users mess up and delete a database or do something wrong, or hackers get into a network and mess up stuff. That's the thing that costs money. Operational costs, that's the day-to-day cost to run the network, which includes the salaries, but also includes the cost of the electricity, the building rental, things like that. And then here are the WAN and internet costs. That's a significant cost as well. Not as high as that, but it is significant, mostly because these costs are contracts that you sign. 3 to 5 years or longer, long-term contracts. So even if you close down a branch of a business, you still have to keep paying that $10,000 a month for that fiber optic line because you signed a contract with AT&T or Comcast or Xfinity that says, I'll agree to pay for that. And they do that, they force you into that because it costs them a bunch of money to run a cable to your building. They're trying to recoup that cost. How do we, as network managers, get costs? How do you guys get costs for stuff? Like if you're trying to redesign a little bit of your own network or buy a new PC, when you're just evaluating, should I replace the laptop I have here? How do you get prices? Anybody? You go to Amazon.com, you go to Google Shopping or whatever, you Google for the pricing. That might be fine if you're looking for the pricing of one item or a few items. But you can't really do that when you're designing a network and you're trying to upgrade 1,000 users. Most organizations use what's called request for proposals. And if you go back to the chapter 6 link in the content area, I have uploaded a couple of sample requests for proposals. Some entities are required to use requests for proposals, like University of Houston, for example. An RFP, and the only way you can really understand what an RFP is by looking at one and realizing what's in one. It's detailed specifications of the equipment that you desire, the software, the services and the expected downtimes or uptimes, those kinds of things, as defined by the network managers and the people designing the network. We might not know who has the best price on something or who can provide services. So we send out RFPs to multiple vendors in the industry, hoping that they will fill in all the blanks. In fact, a lot of times RFPs are spreadsheets. Here's the 25 things that we need. Fill in the blanks for us and tell us what you would charge us for quantity 10, quantity 100, quantity 1,000. How much would you charge us for 3 years worth of internet, 5 years worth of internet, 10 years worth of internet? Typically used in large network purchases. So in the case of U of H, any budget item with respect to networking, and this is probably true for any budget item, this is a state mandate. Anything that costs over $50,000 must go out to bid. The request for proposal is a bid request. It must go to a very generic group of vendors. You can't just pick and choose which vendors. You can't just decide, okay, we'll ask Amazon and Newegg and those Jewish guys up in New York, the camera people, B&H Video and Photo. They've kind of become a little Newegg themselves, or Amazon themselves. U of H, or the state of Texas, there is a list that any vendor that wants to can subscribe to and become an approved vendor for the state of Texas. Then the RFPs are published periodically. I get emails all the time. I'm not allowed to bid on the stuff for U of H, but I can for other entities, like UT, for example. But they send out a request for proposal. Hopefully 2 or more vendors respond. And then those RFPs, there's very specific rules as to, at least for the state of Texas, how those RFPs are evaluated and chosen. Typically the bottom line is, and the deciding factor in most of the cases for the state of Texas is who's the cheapest. Not always, but who's the cheapest? Who can provide the best service is a secondary consideration. It's who's the cheapest. That might not be the case for Exxon or ConocoPhillips or Arthur Anderson. Do they still exist? Ernst & Young, whatever they're called now. KPMG. Multi-vendor proposals versus RFPs that are sent out to single vendors. I happen to be, and you need to know this term, I am what's called a turnkey vendor. Turnkey. Anybody know what turnkey vendor means, or what does turnkey mean? A turnkey provider. Turning a key, like turning the key, unlocking the door to a business. Turnkey means, and this is usually smaller companies, they go to a turnkey provider when they need everything, or they need multiple things. They don't know exactly what they need. They know that they need a phone system. They need a video camera system. They need a surveillance system. They need X amount of workstations. They need X amount of space in the cloud for their data. They'll go to somebody like me and they'll say, give us what you believe is the best combination of all of those items. Who's the best for internet? Who's the best for camera systems? Who's the best for voice over IP telephone services? And I provide them a single price, monthly or a bottom line price for all of these items. It's easier for entities, especially small entities, to do that because they would rather just have one vendor to deal with rather than 10 vendors to deal with or 100 vendors to deal with, because they just don't have the employees. Now, which costs more? I cost more because I'm going to go probably to, if I don't make a certain thing or I don't provide a certain thing, like let's say I didn't provide security alarm monitoring. I install security alarms and I sell the monitoring service, but I'm not a monitoring company. I buy it wholesale from a monitoring company and then I mark it up. I charge a little bit more. So the advantages are to turnkey providers are that it's one vendor that you choose for multiple items in multiple areas, multiple technical areas, and you're relying on their expertise and the fact that they've tested to make sure that that hardware works with these applications, that internet service is going to be adequate for our applications that we are using, that this telephone system is compatible with existing networking services that we already have in place. That's what turnkey or multi-vendor proposals are. Usually not less expensive. They're usually more expensive. Multi-vendor proposals are the opposite of turnkey. This is where you send out multiple proposals to a telephone provider, a internet provider, camera provider, security provider, backup provider, all these different providers. You will save money in the long run, but only large entities can do that because it's too much work and it costs too much money up front. So I want you to look at, and you don't have to do this now, but do it later. Take a look at the sample RFPs that I've posted. I've posted a couple of samples from Fort Bend Independent School District. They're very similar to the same kind of RFPs that University of Houston puts out to the hundreds of different vendors out there. And like I said, everything over $50,000 goes out for bid. If we have to get air conditioning repair or maintenance here at U of H, that goes out for bid to 50 different air conditioning providers. Here's the big deal. How do we get our initial technology design approved? Well, a lot of times we're given a budget, a line item budget that we stay under per year. And if we can stay under that budget, we're good. But usually when you're having to redesign a network every 3 to 5 years, that's going to be over budget. You don't do it every year. You do it every 3 to 5 years. So it's going to be maybe double your budget every 3 to 5 years. So you're going to have to convince your upper management, your boards of directors, that this is why we need to spend 200% more than our normal average yearly budget for the MIS function. Selling the proposal to management, understanding that networks, data centers, and most information technology is viewed as a cost center. As I mentioned this before, MIS management, you are losing money, you're costing money for the business, but you are necessary. Networking has to be managed. We can't just throw hardware and throw technology at employees and expect them to use it properly and expect them to not use it improperly. We have to make business cases to company controllers. And this is why you guys are learning, not just the technical part. I'm teaching you a lot of the technical parts of it. We're just scratching the surface. But this is why you're also taking accounting classes and finance classes and business case classes, because you have to learn how to build a business case, aka systems analysis and design, so that you can give that to upper management, because they're not going to give a shit about, oh well, we can get gigabit speed from so and so for half the price or whatever. It's like, well, what does that mean for us? Do we need gigabit? Or I've read stories about CEOs of companies thinking, how we moved from one building to another, why did we hire a wiring company to come in and rewire this new building for our networking? Couldn't we have just taken all the wiring out of the old building and saved a lot of money and put all that old wiring in the new building? Well, upper management doesn't really understand a lot of times that the technical aspect of that is that the cost of wiring a building, the cost of the wire is 20% of the cost. 80% of the cost of wiring up a building is labor. It'll cost you more money to unwire a building, because that's a pain in the ass. I've had to unwire buildings before and then rewire them because the fire department required it. Maybe it was old wire that wasn't to code. We had to pull out miles of wire. I had to charge them. I said, it's going to cost you money to take the wiring out. What? You got to charge me to take stuff away from me? Yes. Just like the trash people charge you money to pick up your trash. They got to do something with it. Anyway, The importance of network speed, reliability, and security are easy for non-technical users to understand as long as you talk about it in general terms and in monetary terms, saying things like, this will save us an average of $60 per employee per month by going to this new network. They can do some quick math and figure that out and go, oh, okay, that cost will amortize itself out over the next 2 years. And then after that 2 years, we are now saving money. We're not costing money anymore, or maybe less than 2 years, maybe 6 months or a year. We try to avoid, as network managers, as technology designers, on the technical details and the jargon, because it doesn't mean anything for upper management. This works also the other direction, by the way, guys, and I hate this when this happens. I hear from upper management sometimes, or I hear from CEOs of companies or business owners, hey, I heard that there's this new technology that we should use, or I heard that there's this new virus going around and I need to spend whatever amount of money is necessary to keep this virus from getting on our network. Not network managers, company managers, business owners, directors become victims of marketing. IBM, Kaspersky, Norton, these security companies, they scare managers into thinking, holy shit, you're going to get hacked. You need to spend a whole bunch of money and come over to us because we're networking experts, without consulting sometimes with the network managers, or sometimes they get dictated to. Well, you need to go buy this stuff, and the network manager's going, well, that's not the right thing. That's not the right answer. You're just a victim of marketing. IBM, for example, heavily markets stuff that, and some of their products are useful, but it's just another shovel, it's just another car, it's just another flavor of the same tools that are already out there and being used. The deliverables from the cost assessment, by the way, are going to be a final RFP, or basically a bid, or a list of everything that you're buying with the prices on it. And there's two components. What's it going to cost us up front? Our non-recurring costs, our installation costs, and then our MRC, monthly recurring cost. And how long are we in for on that MRC? In other words, are there contracts that we are obligated to pay, even if we decide 6 months from now, screw it, this stuff ain't working, we need to go another direction? Well, guess what? You're stuck with that lease, or you're stuck with that service or that provider for the next 3 years, unless you want to try to sue them and say their service sucks. And people try this all the time with Comcast or AT&T. They say your service sucks. AT&T takes them to court. They almost always win. Very difficult to prove that AT&T wasn't providing you adequate internet service. Implications for management. Network design is increasingly relying on standardized technologies and the building block device. So standardization, very important. I've already talked about that in the previous class. The cost of hardware and the software and circuits is becoming cheaper and cheaper and cheaper in the long run, and humans are getting more and more and more expensive. Humans are also the most difficult to manage, and they're also the most fallible. Hardware, network hardware, and software is getting much better. Software that can auto-update itself, hardware that can manage itself, is much better than using the older school hardware that if it breaks, somebody had to be looking at it every day to make sure it was still running. In other words, managed hardware that you might pay more money up front for managed hardware, but it'll save you money in the long run, because you didn't have to pay some guy to sit there and stare at a computer or stare at logs all day to see if something's still running nominally. Network usage continues to grow, and designing networks with extra capacity is much less expensive than upgrading later. I mentioned that before. That's bit me in the butt a couple times, where I realized, oh crap, I should have gone with that other deal when it was offered, because sometimes really good deals come along. Oh, that's a great deal. and maybe I probably don't need that. And then 6 months from now, you're always, holy crap, I need that. Well, guess what? Now that demand is high and supply is low, I as a vendor, can jack my prices up and ask whatever I want because you didn't sign up 6 months ago when I was trying to give you better deals. MIS managers have to have crystal balls. It's really hard to have a crystal ball, but and again, that's why we never look beyond 3 years, because man, we don't know what kind of technology there's going to be in 3 years. Also, sometimes technology comes about that it's a false start or a failure, like Google Glasses, for example. Who would have thought? Who would have thought that? I would have thought that Google Glasses or having monitors that are literally right here at your eyes would be awesome, and everybody would be using Google Glasses for now. How come nobody's wearing glasses that augment what you're looking at? You guys know what I'm talking about? Google Glass. I think they just call it Google Glass. It was an augmented experience, or video teleconferencing. We're all doing video conferencing and Zoom meetings now, but this technology has been around for 30 or 40 years. It's only just now really taken off because the requirement wasn't really there. Well, it's kind of here now. So there's a lot of false starts with respect to technology that was designed 10 or 12 years ago or more. Buying groceries online, for example. Kroger didn't invent that. H-E-B didn't invent it. Actually, Randall's, which is a local chain, which is almost gone, they had Peapod 20 years ago, where you can buy groceries online and then go pick them up, or they would deliver them to you. So that's it for chapter 6. We'll start on chapter 7 and probably get through 7 and 8 tomorrow. So again, go look at those RFPs. Make sure you look at all of the assignments that are on the assignments page and get them all done. Even if you missed one and it says it's overdue, you should still be able to submit it. Might not be for 100% full credit, but you need to submit it for credit. And you definitely need to do that subnetting assignment, like I said, long before exam 2, which could be up online as early as Monday, maybe as early as this weekend. I don't think we'll get through, well, we might get through all of chapter 7, 8, and 9 by Friday, because I do want to have a Friday class. Any questions? Not seeing any, not hearing any. So I'll go ahead and end the class. I'll post this to YouTube just as soon as I can. I'll diligently work on grading those exam 1s. I don't want you guys to stress about exam 1 yet, okay? You have an assignment called the network game. There is an assignment called the network game. I want you to read through it as it says in the network game, but we obviously can't play it because it's a face-to-face thing, and I haven't figured out a good way to do it over Zoom yet. But I want you to read through it. It's going to do nothing but help you for exam 2 and exam 1, for those of you that didn't do that well. So read through it. Like I said, I'm going to have to replace it with something else, which gives us the same feel. Learning layer 1 through layer 5, what's going on, the transformation of data. See you guys tomorrow, 2 o'clock. Sorry, I lost my mouse. There it is. Go Cougs.